Hi, in this video we're going to talk about a new Cilium feature that came in with Cilium 1.14 called BGP support for external traffic policy, for local external traffic policy. It's quite a mouthful, so I'll take you slowly through it. Some of the videos I've done recently have been about taking existing traditional BGP features and porting them to Cilium. This is more really a Kubernetes focus, and this is about something we call external traffic policy, which is the settings you can apply to your Kubernetes services. Now, if you remember, we use BGP with Cilium and Kubernetes to expose services to the outside of the cluster, to make services that you deploy, an application you deploy in your cluster, available to the outside of the network, outside of the cluster. So what we can do with Cilium is build BGP sessions with your top-of-rack devices and advertise services IP. You can apply different settings to your services. You could have, by default, an external traffic policy, which is cluster-wide. And what we're adding in Cilium 1.14 is also support for the local external traffic policy with BGP. So a cluster-wide external traffic policy means that you would, all the Cilium nodes, let's say, would advertise services to their remote peers, regardless of nodes they have, whether they have healthy endpoints. So what does it mean? That means that, let's say, if you have a service which is essentially fronting endpoints that are across different nodes, even if you were to lose pods on your local node, this node would still advertise it over BGP. So, and that kind of provides some pros and cons here, as you will see later. But the main one is that traffic would be routed, and again, we are still advertising that network to your peer, and this node would advertise the service IP to its peer, even though there's no healthy endpoints. So the traffic will come from here, will reach that node, and then will go kind of across to another Kubernetes nodes. Right? So you have an extra hop here, right? Because again, we have no healthy endpoints, so we have to send the traffic elsewhere. Now, the other disadvantage here is when you use a cluster-wide traffic policy, the source IP of your clients is changed. Right? We always using a cluster-wide traffic policy, the source IP is changed to the one of the node that receives the traffic. So, for example, here again, if you have traffic coming and from a client and it reaches router A and it will go to this node and then back across to this node, the source IP of that traffic would appear to be that of node 1. So you lose the source IP of your client, you lose some information, which is not ideal from troubleshooting or for any other use you may have of the source IP. And what we're adding with this new feature is support for a local external traffic policy. And this is a different approach, and it's where we don't modify the source IP. So you kind of conserve this information, you conserve the source IP. So if you have a client coming here, reaches pod A, pod B, they will always have the original source IP will be preserved. So that's kind of a benefit from an observability perspective. And the other kind of aspects to understand here is that if you were to, let's say, lose pod A or pod B in your node, your Cilium would stop advertising that service, right? If we don't have any healthy backends for this specific service, we would stop advertising. So traffic wouldn't do like it did before, where it kind of reached that node and then went across. It would only the traffic would have to go through the other node. So again, that's just a different approach. And I'll talk about later on about some of the disadvantage that comes with using the local external traffic policy. It's quite a long intro, but it's not an easy topic, so I thought I would just take the time to walk you through the differences between cluster-wide external traffic policy and the local. So let's have a look at the demo. And before we go into the demo, let's just have a quick look at the API specification for services. It also explains the different modes. Again, if you use kubectl explain, you can look at the actual API and the expected value of your services, which again, you have this kind of parameter which can be setting your external traffic policy to either a cluster, where traffic is routed to all endpoints, or local, where you preserve the source IP and you only advertise the services IP outside of the cluster if you have a healthy endpoint. Okay, so let's go ahead first and deploy BGP. So again, because you may have seen some of the Cilium and BGP videos I've done in the past. We are using a virtual environment using Container Lab, which is a great virtual networking platform, and we are deploying BGP on Cilium. First, we're going to deploy some resources that will be a service and fronting a deployment, which is the one we're going to advertise outside of the cluster. So let's have a quick look at our HTTP bean. So you can see we've got the 10.254.0.163. That's the external IP that is going to be announced by Cilium BGP to its peer. And that's fronting the HTTP bean service, which is backed by some pods. So next, we're going to go and use Wireshark to actually visualize the BGP advertisements. It will just give us a bit more information about what happens with when we change the external traffic policy. So first, I'll log onto one of my Cilium nodes, Cilium agent. And so I'll just use a command to get the name of the pod, and then I run share onto the agent. And I then install TCP dump and TermShark, which is a bit like Wireshark, but for terminal, Linux terminal. And again, that will help us just to understand what happens when we modify this traffic policy later on. Okay. So next, I'm going to go back to the terminal, and I'm going to deploy a BGP policy. Again, that's the way we deploy BGP on Cilium. And I'll have a quick look at what it looks like, but essentially we are setting two peering relationships between Cilium. This one will apply to CAN control plane node. I've got two nodes in my cluster, one called CAN control plane, one called CAN worker. And we're setting a BGP session between this node, which is in the AS number 65001, and we are peering with that IP address, that outside device, which is in a different autonomous system number, 65,000. And again, we've got another peering configuration between CAN worker and 169.254.2.1, which is also in the autonomous system 65,000. And let's go ahead and apply it. And then we're going to go and verify that the peering relationship has been successfully implemented. Oops. Right, so we've got Cilium. I'm using Cilium, the Cilium CLI, to look at the BGP peer relationship, and I've got my peers up and running. Right, so I've got the session is established, and we are receiving and advertising some routes. So BGP is working fine. Now we're first going to look at the default configuration for when we're using the cluster external traffic policy. So we should actually, before we do anything, we will show you the service. So this service is using the default external traffic policy, which is cluster-wide. And later on, we will modify that setting and set it up to local. Right? And you will see the difference again. Okay. So what have we got here? So let's head into terminal 2. And what we're doing here is I've logged onto my remote device, and I'm running a show BGP command, right, just to show me the routes. And we are running it every second. We can see the BGP output. So what we can see here is we are receiving two routes to my service, right? So my external device can see two routes from my service, which is from the two Cilium nodes, which is kind of what you expect. We had both Cilium nodes advertise this route to their neighbors. Okay, so what happens when, let's now drain one of the nodes. So we'll remove all the endpoints of one of the nodes, okay? If you recall, this is essentially doing this, right? We are removing the nodes from, the pods from one of the nodes. And what we can still see is we can still see both routes being received by the neighbor, right? So even though we have no healthy endpoint on that node, the Cilium still advertises the routes over BGP. And again, that's the expected behavior because we're using a cluster-wide traffic policy. All right. So again, if we look here, you can see that my HTTP bin pod on kind worker is gone, and it's spending because again we've drained and cordoned the node, so no pods can be scheduled on it. So that's what happened in this scenario. The traffic will this node, even though it's been drained, it will still accept traffic, and traffic will go from your client will hit that the service, and then will be diverted to this different nodes, which in my case is the CAN control plane node. So again, you've got some the source IP has been modified. So let's just see the difference when we use the external traffic policy. First, we're going to uncordon the kind worker node, and now you can see that we are kind of recreating the pods in should all be up and running. Here we go. Now we're going to go and modify that external traffic policy, and we are now going to be using external traffic policy local. And we're going to change the service. As you can see, I've just reconfigured that service. And now we're using the local external traffic policy. And now we're going to see some of the differences. And we're also going to start using TCP term to record the BGP traffic. I'm recording traffic, TCP traffic over port 179, which is BGP. So let's do the same thing again. We are draining kind worker, which means this is what we're doing. We are removing all the pods from this particular node. So the first thing we'll notice is we no longer have two routes for this service. We have just one. Right? This is the expected behavior. Again, using external traffic policy, you would only advertise the service over BGP if you have healthy endpoints. But because we've drained the node and cordoned it, there's no healthy endpoints for this particular service, which is why we only see one route. And then what we can also do now is a quick look in using term sharp. You can see this update message here. And if we look, this is a BGP update message. And what you can see is we've withdrawn a route. We've removed a route. We've stopped advertising. And this is what happens again when you use a local external traffic policy, is that you would say, this route is no longer valid, and you tell your peer. It's all very clean. This is standard BGP behavior, but this hopefully helps you understand what happens in the background here. Is we tell our peer we are no longer advertising this route because again we don't have any healthy endpoints. So that's again that's the behavior you would get with external traffic policy set to local. The one kind of drawback you have to understand here is this one. External traffic policy, when it's set to local, it just treats each node as the same from a load balancing perspective. So what does it mean? It means that, let's say if I've got 5 pods, that's unlikely. If let's say if I have 5 pods in node 1 and 1 pod in node 2. But if I were to have this kind of imbalance here, what would happen is that 50% of the traffic would go to node 1 and 50% of the traffic will go to node 2. Right? When you use local external traffic policy, our external device, they don't really see the different nodes. They just see don't see the different pods. They just see 2 different nodes. The traffic will be 50-50 between these 2 nodes, which means that this pod F would receive 50% of the traffic, and all these 5 pods will each receive 10%. So that's the kind of compromise you have to make here from a kind of architecture decision, right? So you either have this local external traffic policy or cluster-wide, and as you can see, they come with their pros and cons. Okay, wow, a really long session, but I hope you found it useful. I had to go a bit deeper into BGP services and Kubernetes and obviously Cilium, but I hope you found this useful. Thanks very much for watching, and have a great day.